Hello everyone, welcome back to my channel once again. In this video we are decoding the periodic table. We will learn about the arrangement of elements through this video. So let's begin. How many elements can you name so far? Okay, so here I have given you hint that you will understood which elements are there in around your area, so we can understand so their names. Okay, so today you will be able to learn about the role Mendeleev played in the early development of the periodic table, then highlight, label and locate groups, periods, blocks, metals, non-metals and metalloids in the periodic table, and also describing the patterns and trends in the periodic table. So who was Mendeleev? In 1869, the Russian chemist Dmitry Mendeleev produced one of the first practical periodic tables. His work laid the foundation of the modern periodic table only. The most amazing part is that Mendeleev's table of elements left spaces for the yet to be discovered elements. So there is a place to put the new discovered elements. So who was Mendeleev now? Let's understand about him. Before Mendeleev, chemists had grouped elements based on their common properties like being a gas or highly reactive metal, or they were grouped based on their atomic mass. Now, Mendeleev saw a way to combine the two approaches, atomic masses and common chemical properties, into one simple table. He just classified according to the atomic mass in one table and another chemical having the common chemical properties. For example, gases are at one place and solids are at one place and liquids are at one place, like that. So now think, pair, share. Okay, so here Mendeleev's and modern periodic table, what is the difference? So research Mendeleev's original periodic table online and compare it with the modern one used in your class. Okay, this is for your homework. List at least 3 differences or similarities between the two periodic tables. One more. Some of the characteristics of Mendeleev's periodic table include, what is it? Mendeleev arranged the elements according to increasing atomic mass. It is increasing atomic mass. Then Mendeleev did not include noble gases in his periodic table since they were discovered later. Mendeleev's version had columns for groups and rows for periods. Now the modern periodic table, just observe this carefully. There are 118 elements in the modern periodic table. The elements are arranged according to increasing atomic number. Okay, in Mendeleev's periodic table, it has the increasing atomic mass. Each box contains one element. Now the periodic table period. Period means what? The rows. The period is a row of a table. Rows run horizontally. So there are total 7 periods in the modern periodic table. Okay, how many? 7. Just pause it and count it again. I also show it with the dark color. Okay, now next. So the two rows below the periodic table are lanthanides and actinides, the below one which has the yellow and little bit green color, collectively called the inner transition metals. They also known as inner transition metals, which are lanthanides and actinides. Now lanthanides are often called rare earth elements. Lanthanides are often called rare earth elements, while actinides include mostly artificial elements with a few exceptions. These are the artificial ones. Now the periodic table group. A group is a column of the table. Columns runs vertically. There are total 18 groups in the modern periodic table. You can see there groups 3 to 12. 3 to 12. Okay, 3 to 12 are sometimes labeled as transition metals and also referred to as D block elements from 3 to 12, the middle part of the periodic table. It has name, that is D block element. We will understand why it is given the D number name. Sorry. The numbering 1 to 8 is established by IUPAC. We just saw in our previous video what is IUPAC. Then modern periodic tables use the conventional Roman letters, conventional Roman numeral plus letter combination, that is group 1 is also labeled as 1A. Okay, Roman numeral also a letter. Group 1 is also known as 1A. So groups 3 to 12 belong to group B, while group 1 to 1 and 2 and 13 to 18 belong to group A and also known as representative elements. Okay, while 1 and 2 and group 1 and 2, that is the hydrogen. Okay, you can see the hydrogen group, and the next one is the beryllium group. So and 13 and 18, 13 which start with boron and 18 which start with the helium. Okay, these are known as representative elements. Metals or non-metals, how do we understand? Okay, metals are nothing but they are having a good conductors of electricity and thermal energy. They also have high density, means heavy. Then malleable means you can malleable, means you can mold them in any structure, and they are also having high melting points. Okay, so which are the green in color? They all are metals. You can see there, green in color, light green. Okay, next, metals or non-metals. Here now we are seeing about the non-metals, which are in purple in color. So the poor, these are the poor conductors of electricity, that's why they are known as non-metals. Also the less thermal energy, also having opposite to metals only, low density, brittle, means you can easily break them, low melting points. Okay, think about it. What are the elements in yellow collectively now? We know the green part is the metal, purple color is the non-metal. What are the this yellow color having the elements? Okay, let's see. So these are the metalloids. Okay, what is the metalloid? The properties of metalloids can be similar to metals and non-metals. Okay, they are showing the properties, little bit of metals and also little bit of non-metals. So they appear to be more like the non-metals, but some can conduct electricity. Okay, some can conduct electricity, for example silicon. So these so-called also called as semiconductors, because they are not totally conductors, that's why we are saying semi, which is half. Okay, so examples are silicon, G and Sn are useful in many electrical devices. Now periodic trends. What is the trend? Periodic trends are repeating patterns found in the modern periodic table as you move across a period or down a group. Okay, this is the fourth group. Now we have took the fourth group. So one periodic property is the effective nuclear charge. Okay, it has the nuclear charge. It is a measure of ability of protons in the atom's nucleus to attract the electrons in orbit around the edge of the atom. So how would the nuclear charge change as you move across a period? How it is changing? See, you can see 19, 20, 21, 22. It is increasing. So nuclear charge is increasing. Next, the effective nuclear charge increases across a period. It is increasing across a period, means it is increasing across a period, that is horizontally. Okay, we are thinking about the groups, not periods. Okay, on the other hand, it decreasing down a group. Okay, when we are thinking about the periods, it is increasing, and when we are thinking about the groups, it is decreasing when it is going down. So on the other hand, it is decreasing. What is the nuclear charge? Because of increasing number of shells. Now periodic trends, about here we are thinking about the atomic size. In relation to the nuclear charge, the atomic size generally decreases as you move across the period. Consequently, atomic size increasing as you move down the group. It is increasing as the number of electron shells increases. That's why the atomic size is also increasing. There is a larger distance between the nucleus and the outermost orbital. Next is the, as you descend group 1, the reactivity of the elements increases drastically. So reactivity, how they are having the reactive, means how much they are reactive. This is due to in part that increasing effective nuclear charge. We also seen that in periodic groups the nuclear charge is increasing, that's why reactivity also increasing. But in group number 18, it is also this group number 18 is also called as noble gases. They are very stable due to their filled valence shells and are less likely to react with other elements. So here, can you identify more patterns in the periodic table like this? Let's see. Work with a partner, and this is a homework. Okay, answer the prompt on each card using what you have learned in the lesson. So these are the four cards. Okay, in first card it is given chlorine, that is a Cl. Okay, is found in group 17. Predict whether it is metal or non-metal. It is found in a group 17. Now francium, that is Fr, is found at the very base of the group 1. Okay, what would you expect? This is added to the water, what will happen? Helium is located at the rightmost part of the periodic table, that is, helium is also a noble gas. So what can you say about its atomic size? Now fluorine is in group 17, like in chlorine, is highly reactive. Iodine is found below fluorine. Make a prediction about the reactivity of iodine. Now which is the reactive one, fluorine or iodine and chlorine? Okay, now, patterns and predictions. Okay, here the already given the answer. Okay, chlorine is a non-metal. Yes, it is in group 7, so it is non-metal. Okay, because we just have seen about the metals. Then francium will react explosively. Okay, which is at the base of the group 1, which is, okay, francium will react explosively, and helium has the smallest atomic size because our atomic size is increasing. Okay, then next, iodine would be less reactive than fluorine because reactivity is decreasing when we are going to the downward side, that is a group wise. Okay, so what we have learned, according to Dimitri Mendeleev, he produced one of the first practical periodic table. His work became the basis of the modern periodic table. On this basis, the modern periodic table has done. It has vertical columns and groups and horizontal rows called periods. Its arrangement allows us to look for patterns in the properties of the elements. So here we have finished about the periodic table. I hope you have understood about the periodic table. If you like this video, like and subscribe my channel, and also share with your friends. Thanks for watching.